This question looks very similar to the one we just solved before. But let's go ahead and take a look and see what happens. So we're given the same exact table that shows an arrangement of electromagnetic radiation according to their frequencies. And the first question, how are electromagnetic waves generated? Well, we've talked about this before. They are generated by accelerating electric charges. If you accelerate electric charges, you get electromagnetic waves. You generate electromagnetic waves. So that is the answer to the first question. The second question, what type of electromagnetic radiation has the highest energy? We know that energy is equals to Planck's constant multiplied by the frequency. So the higher the frequency, the higher the energy. So it's just a matter of going to a table and seeing which type of radiation has the highest frequency. And clearly it is gamma rays. Gamma rays have the highest frequency with 10 to the power 18 to 10 to the power 21 frequency. So there we go. The answer to our second question is gamma rays. A certain type of electromagnetic radiation has a wavelength of 600 times 10 to the minus 10 meters. Identify the type of electromagnetic radiation by performing a calculation. I think in the previous question, we were given the energy and we calculated the frequency. Here we are given the wavelength and we are going to do the same thing because what we have is type of radiation and a type of frequency. So we just convert whatever we have to frequency, and then from the frequency we calculated, we're going to be able to identify the type of radiation. So let's go ahead and take a look. We know that speed in our case denoted by C in electromagnetic waves is equals to the frequency multiplied by the wavelength. So C, speed of light, 3 times 10 to the power 8. Don't forget, the speed of all electromagnetic waves is always 3 times 10 to the power 8 meters per second. The frequency is what we are interested in. And the wavelength, we have 600 times 10 to the minus 10 meters. Well, you can see what we need to do here. We need to divide both sides by the coefficient of frequency, which is 600 times 10 to the minus 10. 30 times 10 to the power 8 divided by 600 times 10 to the minus 10. On the right hand side, those two will cancel out. 5 times 10 to the power 15 hertz is equals to the frequency. So now it's just up to us to identify which frequency is 10 to the power 15 in our list provided. Clearly it is ultraviolet, 10 to the power 15 to 10 to the power 16. So that's our answer to question 3, UV. So the fourth question, state one application of the type of radiation identified in question 3.4.1. Ultraviolet light can actually be used to kill bacteria. So that is just one of the application of ultraviolet light.